Welcome to viewers. We are discussing similar triangles, lesson 6 of class 10 CBSE curriculum. Two triangles are said to be similar when corresponding angles are equal and corresponding sides are proportional. Now you see in figures, in both figures, these two triangles ABC and PQR, here also ABC and PQR, they are similar triangles and their corresponding sides are proportional. They are not equal but proportional. AB by PQ, BC by QR, AC by PR equal to K constant. Corresponding angles are equal, right? A equal to P, B equal to Q, C equal to R. Both cases. These two right angles are similar. Corresponding angles are equal. Corresponding sides are proportional. Now you see in these two triangles, ABC and DEF, they are congruent and they are also similar. Because in congruent triangles, by virtue of CPCT, we know that corresponding angles are equal and corresponding sides are also equal by virtue of CPCT. So you find that their ratio is also 1. That means they are proportional. So if two triangles are congruent, they must be similar. But if two triangles are similar, they may not be congruent. For example, these two triangles are similar, but they are not congruent. One triangle is smaller than the other, right? So congruent triangles are similar, but similar triangles may not be congruent. Now, before discussing the criteria for similarity of triangles, we will discuss a few proportionality theorems here. So before discussing proportionality theorem, we discuss basic properties of area of triangle. Let us find the area of triangle is half of base into height. You remember this theorem? Area of triangle. This is suppose base, and let us make perpendicular from the opposite vertex. This is height. So area of triangle equal to half of base into height. Now think about this obtuse angle triangle. This angle is greater than 90 degree. Now considering this as base, suppose this is base. So what is the perpendicular here? Let us draw the perpendicular from the opposite vertex. So this is the perpendicular height, right? That means in case of obtuse angle triangle, height or perpendicular, it remains outside the triangle. Here also area equal to half of base into height. Area of the triangle equal to half of base into height. Again, let us remember one important property we discussed in class 9. Say these two lines are parallel, suppose L parallel to M. Now think about this line segment, suppose AB. Now taking AB as the base, you make some triangles here. Now these triangles APQ, APB, AQB, ARB, etc. Area of triangle APB, this is B, equal to area of triangle AQB equal to area of triangle ARB, etc. That means triangles in between two parallel lines, L parallel to M, and on the same base, AB, base is common here, they have equal areas, right? Two or more triangles on the same base and in between parallel lines have equal area. So we will use this property in discussing the proportionality theorem. Let us first discuss the theorem number 1. A line parallel to one side of a triangle divides the other two sides in the same ratio. Let us take this triangle ABC. This is triangle ABC. Let us draw a line parallel to BC. Say it is DE. Right? So you are given that DE parallel to BC, right? To prove that this line DE divides AB and AC in the same ratio. AD by BD equal to AE by EC. We have to prove that this line D divides AB and AC in the same ratio. Now to prove this, let us draw perpendicular from D on AC. This is suppose F, and another perpendicular you draw from E on AB. This is suppose G. And let us join BE and CD. Right? So to prove this, we draw perpendicular DF perpendicular on AC. EG, this is perpendicular on AB. Then we joined BE and CD are joined. We have joined this. Now you see area of triangle ADB, ADE, half of base into height. So what is base? Considering AD as the base, if you consider AD as the base, half of base into height EG, right? This is 1. Again, area of triangle ADE. If you consider AE as the base, AE, then perpendicular will be DF, right? This is 2. Now, area of triangle BDE, half of base into height. What is base here? If you consider BD as the base, BD or DB, DB into EG, half of base into perpendicular. If you consider BD as the base, EG is the perpendicular, right? You see this triangle. Perpendicular lies outside the triangle. This is D, B, E, and this is G. So area of this triangle is half of base into height. Height is outside the triangle. Area of triangle CDE, half of base CE, perpendicular is DF, right? Now you see area of triangle BDE equal to area of triangle CDE. Why? Triangles on the same base. Same base is DE, and between two parallel lines. What are the parallel lines? DE parallel to BC. So triangles in between two parallel lines and on the same base, they must have equal area. So DE, this is triangle B, and this is triangle CDE. So CDE and BDE, they are on the same base DE, and in between parallel lines DE parallel to BC. So their area equal. Now you see we can compare these ratios. Suppose area of triangle ADE, area of triangle BDE. What is this area? ADE, half of ADEG. Area of BDE, BD multiplied by EG. This you find AD by dB. This is suppose 3. Then you find area of triangle ADE by area of triangle CDE. Area of triangle ADE can be written as AE by AE multiplied by DF, and here CDE, CE multiplied by DF. So you find this DF by AE by CE. This is say 4. Now here you find the left hand side circle, since because they are numerator circle and denominator circle, right? BD equal to CDE, ADE is same. Area of triangle ADE by area of triangle BDE equal to area of triangle ADE by area of triangle CDE. Since because their denominators are same, we find it out. Triangles on the same base and between parallel lines, numerator circle. Therefore, since left hand side circle, right hand side circle, AD by DB equal to AE by CE. This was proved. This has to be proved, right? So we find that this parallel line DE parallel to BC, DE divides AB and AC in the same ratio. AD by DB equal to AE by CE. Now let us prove the converse of this theorem. The converse of this theorem is, if a line divides two sides of a triangle in the same ratio, then it is parallel to the third side. That means we will be given that AD by BD equal to AE by CE. We have to prove that DE parallel to BC. So let us try to prove the converse of this theorem. If a line divides two sides of a triangle in the same ratio, right, then it is parallel to the third side. So this time we are given DE divides AB and AC in the same ratio. So we are given AD by DB equal to AE by EC. To prove, what is to be proved? DE parallel to BC. We have to prove that they are parallel. So let us prove this. So first we will assume that, let's assume DE not parallel to BC. DF, we consider another line, F. DF is parallel to BC. Suppose DE is not parallel to BC, we consider DF parallel to BC. We are assuming this, right? So if DF parallel to BC, then AD by DB equal to AF by FC. Why? A line parallel to one side of a triangle divides the other two sides in the same ratio. This is by earlier theorem. A line parallel to one side of a triangle divides other two sides in the same ratio, right? So AD by BD equal to AF by FC. But we are given AD by DB equal to AE by EC. This was given condition. So from this two you see left hand sides are equal, therefore right hand sides are same. Therefore AF by FC equal to AE by EC, right? Now let us add both side 1. Let us add 1 both side. AE by EC plus 1. Adding 1 both side. So you find denominator is FC. AF plus FC. Here denominator is EC. AE plus EC. Now what is AF plus FC? AC by FC. What is AE plus EC? That is also AC divided by EC. Now you see these two fractions are same and numerators are same. Therefore, their denominators must be equal. FC equal to EC. Now when can you say FC equal to EC? FC equal to EC is possible when F coincides with EC, right? It is possible only when E and F are same point. That means F coincides with EC. If F coincides with EC, that is DE parallel to BC, right? If F coincides with E, F and E are the same point. That means DE and DF are the same line. That means DE parallel to BC. So this was to be proved. So this is converse of the earlier theorem. Earlier theorem was if a line is drawn parallel to one side of a triangle, it divides the other two sides in the same ratio. Here we find that if a line divides two sides of a triangle in the same ratio, it is parallel to the third side. So we prove that if AD by BD is equal to AE by EC, DE is parallel to BC. So thank you viewers for watching these theorems. I hope you understood the logical of these two theorems, logics of these two theorems. They are reciprocal of one another. Using these two theorems, we will discuss some numericals in the next video. Keep in touch.